Welcome students to differentiable equation. Differentiable equation of first order when you have y prime like this example. It will be of second order when we have y double prime. Okay. Now we're going to start by differentiable equation of first order when we have y prime. First case when you have, it's called separable variable, when you can put the x alone and the y alone. We integrate on both sides. Example, suppose you have y prime equals sine x. Y prime is dy over dx equals sine x. So here you have y apart and sine apart. So you integrate, you're going to get y equal minus cosine x plus c, where c is a real number. Another example here. First of all, if you look at this one, you can say that y equal to 0 is a particular solution. Why? Because if you put y 0, this is a particular solution or single solution. If y is not 0, y prime is dy over dx plus y. You take y to the other side. Here you have dx over x. Here you're going to have dy over y, and you have the minus here. You integrate both sides. This is called separable variable. So len absolute value of y equal minus len x. Here we said x is bigger than 0, so we don't put absolute value, plus k. Now I want to find y, so y equal e power minus len x plus k. If you remove the absolute value, put plus or minus. Minus len x can be written as len 1 over x ek, and e power len 1 over x. Here it will be 1 over x, and if you remove the absolute value, you have plus or minus 1 over x ek. Plus or minus ek, it's a constant because k is a constant, so it can be written as c over x, where c equal plus or minus ek, or you can say c is a constant belong to R. Suppose I want to find c, I gave you a particular solution for x equal to 1 and y minus equal to minus 1. If you replace it, you're going to get c is minus 1, and you replace. So a separable variable, you can put x alone and y alone. Now, second part of first order differentiable equation, when we have variable coefficient, here you have the variable coefficient for y, and without second term, and here it's equal to 0. This is called the second term. You want to write it as y prime if it's of the form y prime plus y with coefficient of x equal to 0. So here we say second term is without second term, and coefficient here of y is variable. So it's of the form y prime plus axy equal to 0. If you have this form, our y equal to 0 is single solution. For y not 0, the y prime dy over dx, you take this to the other side. You bring y here, it will be over, and you take dx up. You integrate both sides, so you're going to get len 1 len y in absolute value equal minus integral ax dx. So what I want you, when you have this form, you memorize the formula instead of doing all of these. No need to do it. For example, y prime plus sine xy equal to 0. This is of the form y prime plus ax y equal to 0. So first of all, y equal to 0 is a particular solution. If y not 0, directly you can go here. So len y equal minus integral of sine x. Minus integral of sine x, directly you can write it, so it will be cosine x plus k. So if you remove the absolute value, you're going to say y equal e power cosine x plus k, and you can split it, and y equal plus or minus e cosine x ek. So plus or minus ek, it's a constant c, so the answer is y equal c e cosine x, where c is a real number. And if you want to determine a particular solution for x is pi over 2 and y is 1, so replace here y by 1, cosine pi over 2 is 0, so c is 1, and you replace it. Here this is the same story, it's of the form y prime plus axy equal to 0. So directly we can start by here, len y, it will be integral of minus 2x, integral of minus 2x, which is here minus x squared plus k, so y equal e minus x squared ek. So directly when you have this one, you can jump here, so y equal c e minus x squared, where c is a real number. This is called the general solution of the equation, and the particular solution here if y is 0. Another form, when you have y prime plus ay equal to 0, where the coefficient is a real number, constant, and without a second term. So here y equal to 0 is also a singular solution. So if you solve it, you're going to have this one. You put y here and you take up x. So directly if you solve this one, len y in absolute value equal minus ax plus k, so y equals c e minus ax. So directly memorize it. So if you have y prime minus 3y is 0, so this is of the form of this form. Directly y equal to 0 is single solution, don't forget. Say if for y not 0, we have y equal c e power minus ax. A is minus 3, so c e power 3x. And if you have y equals c e minus 4x, so this is the differentiable equation will be what? Y prime plus 4y equal to 0. And if you have y equals c e 5 over 2x, so y prime will be y prime minus 5 over 2 y equal to 0, which is this one. So you need to memorize the formulas. Now if you have of the form y prime plus ay equal to b, where the coefficient is constant, but we have a second member here like b. Y prime plus ay equal to b. If a is 0, we have y prime equal to b. So dy over dx equal to b. So dy will be b dx. If you integrate both sides, you have the general solution here that you have. If a not 0, what do? We take this to the other side. So you have y minus b over a. So we're going to say let big y equal y minus b over a. So if you derive here y prime, you're going to get small y prime. So we're going to write in big y prime. So y prime here, sorry, we don't have equal. So equal to minus ay صح. So this implies y prime plus ay. Here we don't have 0. Y prime plus ay equal to 0. Y prime plus ay equal to 0, we did it now. And the one before, we said y equal, big Y equal ce power minus ax, where c is an arbitrary constant. But since y, big Y equal y minus b over a, so we're going to replace it. So we're going to have plus b over a. What I want you, we're not going to do all of this. We need to memorize this one. If you have y prime plus ay equal to b, so the differentiable equation will be the solution, the general solution will be y equals ce minus ax plus b over a. If you have equal to 0, it will be y equals ce minus ax. So here you have what's called y1 plus y2. y1 is the general solution, which is ce minus ax, and b over a is called particular solution of y prime plus ay equal to b. Okay, so this is the particular solution. Let us take example to understand. If you have y prime minus 2y equal to 7, so this is of that form, a prime, y prime plus ay equal to b. So directly you write y equals ce power 2x plus b over a, plus b over a and a minus 7 over 2, the general solution. This is cet of x is called the general solution, and this is minus 7 over 2 is called the particular solution. And if you have y equals ce minus 4x plus 5 over 4, you need to memorize. If you have this form, directly the differential equation will be y prime, opposite side of minus 4x is plus 4y. And here the b is 5, because I want b over a, which is 5 over 4. And if you have it that form, so y prime minus 2y equal, I want b over a, and b over a must be minus 3, and since a is minus 2, so in that case b will be 6. Now if you have y prime plus ay equal a function of x, what do? If a equal to 0, we have y prime equal f of x, we integrate, we get this solution. It's very simple. If a not 0, we're going to write it as general solution plus particular solution. So the general solution, when you have it, first of all, you're going to write it as equal to 0. If it's equal to 0, we did before, y1 equals ce minus ax, and we're going to find y2 depending on the problem that we have and on the given. So let us take example. If you have y prime plus 3y equal x squared plus y. Find general solution of the equation y prime plus 3y equal to 0. So directly y1 equals ce power minus 3x. Now find the particular solution of the 4. They gave us it must be a 2ax squared plus bx plus c. So I want y prime. So I derive it. It will be 2ax plus b plus 3. I replace it here into 3ax squared plus 3bx plus c. I want to equate it to what? To x squared plus 1. Coefficient of x equal coefficient of x. In here 2a plus 3b. I don't have x equal to 0. X squared 3a equal to 1, and etc. So I want to get a is 1 over 3, b minus 2 over 9, c is equal 11 over 27. So this is the equation. So I write ce minus 3x plus the particular solution that I have. Now I want to continue in the second video the differential equation.